Try and see the back side of your head. It's impossible. You can't do it unless your eyes are on a pair of stalks or you have a couple of well-positioned mirrors. You can't do this. But why can't we do this? Why do we live in a universe where it's not possible to see the back of your head? And how would it have to change for us to be able to? So it turns out that the important thing here is the curvature of the universe. So let's start by thinking about a universe with no curvature. We call this a flat universe. And it's the kind of universe that you're used to. It's the kind of universe that we think we live in. And in a flat universe, if I get in a spaceship and travel in that direction, well, I can just keep going and keep going and keep going, because flat universes go on forever. They have no boundaries or walls. They have to be infinitely big. And also, if you can remember back to those boring laws of geometry, which you probably learned about at primary school or secondary school, things like pairs of parallel lines staying the same distance apart forever and never crossing. Or if you draw a triangle and add up each of the 3 internal angles, it will sum to precisely 180 degrees. Well, they apply in a flat universe. So that's a boring, infinitely big, flat universe where you can't see the back of your head and angles in a triangle add up to 180 degrees. Let's now curve our universe up a bit. If we give it a bit of curvature, we now call it a closed universe. And in a closed universe, if I get in my spaceship and travel in that direction, well, eventually, if I keep going, I could end up coming back to where I started. It's a bit like taking a round-the-world trip from Birmingham International Airport. If you travelled in a straight line and kept going, eventually you'd come back to the airport that you started at. And in one of these closed universes, if I had a long enough stick, I could poke myself in the back. And if I had really good eyes or a powerful enough telescope, I might just be able to see the back side of my head. So this is quite cool, but then these closed universes do funny things to those boring laws of geometry too. Remember parallel lines? Well, in a closed universe, parallel lines will eventually cross. And again, this is like the surface of the Earth. If you take lines of longitude, which are parallel at the equator, at the North Pole, they cross. And angles in a triangle. If you draw a triangle in a closed universe and add up the 3 internal angles, they will add up to more than 180 degrees. And you can try this at home. If you take a really big vegetable or something round and draw a triangle on it and add up the angles, you'll find that it adds up to more than 180 degrees. So that's something for you to try at home. So we can actually use this. We can try and determine whether we do indeed live in a flat or a closed universe. Not just by squinting and trying to see the backs of our heads, but we can draw really big triangles. So that's what we do. We drill triangles that extend from the Earth out to one corner of the observable universe, round to another, and back to the Earth. And we add up each of the 3 internal angles and find that they add almost exactly to 180 degrees. This tells us that our universe is indeed flat, and you can't see the back of your head. Thank you for listening.